Hello, biology. How are you guys doing? Made it through your first week of homeschool, sort of distance learning. Distance learning is what we're calling that. So you guys finished up chapter 20. You were supposed to do chapter 19 and 20 study guide. I sent that to you guys to try to print out. If you did not get that, text me and I can send it to you again. If you can't figure out how to print it out, you can always just do it on a separate sheet of paper. And then I'm going to try to get to the school today and print out some of them that are, I can just lay there if you want to pick them up on Monday or something if you haven't done them yet. Hopefully you've done it already. But keep those. Don't turn those in to me until we get back, unless I tell you otherwise, because I want you to be able to study them. So go over chapter 19 and 20. That's what you'll have a test on first. And if for some reason this were to go even longer than after spring break, then I'll probably figure out how to give you an online assessment of that test so we can move on from that. So now we're moving into chapter 21, and these are basically other types of invertebrates. We were talking about insects and arthropods, insects, crustaceans, arachnids, centipedes, millipedes, which, by the way, there's a lot of videos that I put on my channel that it's just one of my playlists, and on that playlist says something, it's titled something like videos for you to watch this week, or something that will help you this week, something like that, and on week 2, something like that. But anyways, there's a lot of arachnid videos that I normally would show, and they're only like 1 or 2 minutes long each. So I would say watch some of those and then let me know if you do. There might be some bonus points in there. I think there's about 5 of them, 5 short ones. So then the largest group of water animals on the earth those are called mollusks. All right, these are soft-bodied, boneless creatures. All right, so they don't have any bones. Like clams, oysters, slugs, snails, conchs, cowries, squid, octopus, that kind of thing. Some snails and slugs live on land, but other than that, all those live in the water. Mollusks are distinguished. They have a muscular foot, is what they're called. Some of them, the muscular foot comes out of their stomach. Some of them comes out of their head. Some of them, it's just like one big weirdo muscle. And so, anyways, that's what they use for movement, for locomotion. They also have a visceral hump that has all their organs in there, and then they have a mantle, which is a skin-like organ that kind of covers the visceral hump, and then it will produce calcium carbonate in most of those species, and that will produce the shell. So the shells are made up of calcium carbonate. All right, you can read most of this, but there's lots of species of them, about 100,000 living species, and 100,000 in the fossil record that they know of. So both. So these mollusks are going to be divided down into 6 different classes, and we're going to talk about each thing. Okay, so most familiar would be bivalves. That's pretty easy. We'll talk about those. Then you have gastropods, univalves, cephalopods as well. Let's see here. I can't think of one. Gastropods, univalves, cephalopods. Those are 4. Oh, we're just doing the 4. I'm sorry. We're doing the 4 that are the most common, not all 6. But now I'm going to have to look up. I can't remember the other 2 off the top of my head. Anyways, all right, so bivalves, these are easy to remember because they have a valve that connects them and 2 shells. So what does that look like? A clam. Doesn't it look like a clam? Clams, oysters, mollusks, good eating. Those are also called shellfish, and each shell of a bivalve has 3 distinct layers, like talking about the actual shell. Inside of that, it's going to have a hard, rough kind of outer layer, sometimes having little like sprouts of horns or little things that are kind of coming off of it. And then you have a crystalline middle layer, and then you have a pearly inner layer. So if you crack those open, they have these like really pretty, almost mother of pearl look in them. And the brilliantly colored mineral deposits, a lot of times those are used for making jewelry and buttons and all kinds of other stuff. And that is usually called mother of pearl, like a true mother of pearl. So those are bivalves. There's you can look at a bivalve anatomy on page 430, and you can see what those look like there on page 430. You can also look on page 429, and you'll see a different type of bivalve, and this would be an oyster, and they're talking about the formation of a pearl. So a pearl is really cool. It gets there's like a little sand grain is irritating the lining in an oyster, and basically it sits in there and it's kind of irritating it, and it will secrete this nacre all around it. That's just what's the pearly layer on the inside of the mother of pearl. That's how it's formed, but instead it continues to form this around it. It's kind of like if you get a piece of sand or a little rock stuck in your shoe. We can get it out easily, but they can't. So if we couldn't get it out, we'd want to cover it with something, so it wouldn't be so irritating. And so that's what it does. And so those are true pearls that they actually get. Those are called pearl oysters that do that. And most of the pearls valued as gems, they come as this, and they come from the tropical seas, warmer seas there. And some of them are extremely valuable. Now, most of the pearls we see today are either artificial or they're created in a lab or something along those lines. But a true pearl is really a thing of beauty. Now, on the bivalves, they have what they call adductor muscles, and these adductor muscles are extremely, extremely strong. If you've ever taken a clam or an oyster or something and tried to pry it open, you really can't do it. That's why usually, if you're just, a little cooking tip, if you're going to cook those types of things, mussels or whatever, then if you can open them, that means they've been dead for a while and you want to discard those. You want living ones and you can't get them open, that's good. You stick them in a pot of boiling broth of some sort, and then they open right up, and then they're fresh and you can eat them. If you like that kind of thing. I do. So anyways, they use their foot, and you can see on the bottom of page 429 how they do that. They take a muscular foot, comes out of their shell, and they push it down into the sand, and that forces blood to the end of the foot, and it causes it to swell. And so then it will shorten the foot if it wants to move and let the water take it, or if it wants to stay put, it'll put that foot down into the sand and leave it down in there so it can stay in there. So those are the abductor muscles. And, I also put some videos on that little fun thing to watch of a starfish eating a clam, and the starfish actually injects its stomach into the clam, and it actually is so strong that it can pull the two clam shells apart and stick its stomach down into the clam, digest the clam, and then pull its stomach back in, and then leave the shells for us to collect. So you can they have an in-current siphon and an ex-current siphon that basically siphons water in. It gets the oxygen that it needs from that, and then an ex-current siphon, it siphons the water out and sends the water out there. They have an open system of circulation, and of course most of them are edible, a lot of them anyways. Clams, oysters, scallops, those are most popular, but they are considered scavengers, so they used to not be able to be eaten by Jews. So maybe they don't eat them now, but anyway, moving on. Those are bivalves. All right, now we're moving on to gastropods. All right, gastropods, if you think of where gas comes from as far as in your stomach, then you would remember this one. Pod means foot, so gastropod is stomach foot is what that means. So it has a foot that kind of comes right out of the center, out of the stomach area there. They're often called univalves because they have one shell instead of two, and you can see that on the bottom of page 430. They're beautiful. Some of them don't, like the slug. They don't even have a shell, but most of them do. A snail would be in this, a conch, a cowrie, a nudibranch. That's one of my favorite words, and so those don't have shells either there. And gastropods range in size from really small, like the size of a pinhead, all the way up to 2 foot long aquatic snails. I do not want to see a 2-foot snail. And so like bivalves, univalves have a foot, a visceral hump, a mantle, and usually a shell. And, so that's pretty cool. Just a minute, because that's lunch. So I'm going to tell Brayden He's coming to get lunch. So gastropods, snails are helpful because they clean up organic debris and that kind of thing. They're commonly served for food as well. I did have snails. Escargot is what you call that whenever we were in France. And I never dreamed that I would, but Sam Lee really wanted to have snails. And he said, I want to try that. And I had really preached to these kids that, they should be trying new and exciting things. And so I kind of ate my words and the snails. And they were actually pretty good. Butter and herbs make anything taste decent. They were kind of like a clam or a mussel or something like that. Anyway, so you can see that. Oh, they have a thing called a radula. All right, radula. You see that on page 431, and it is a file-like organ that scrapes food, and it carries it from its mouth or oral cavity there, like a conveyor belt into the digestive tract. It's just like into the digestive tract. And that's called a radula. And that's something kind of interesting. If you look down on page 431, you can see how that radula works. All right, so it just kind of picks it up and kind of conveys it back to the digestive tract, which they have a crop, which kind of stores their food until it's needed. And then you can see all the different organs there as well. Then you have the next one. It's called cephalopods. All right, so we've had gastropods, stomach, foot, bivalves, two shells. Now we have cephalopods, and that means head, foot. And if you think of what an octopus or a squid look like, that's their muscular foot, actually, that comes out of their head. And that's kind of how they can move. They both can, usually the squid has about 10 tentacles, and the octopus has 8, hence oct 8. They actually have jet propulsion, which means they kind of siphon the water in and then push it out. And as they push out that water, it maneuvers them, makes them be able to move. Some squid, let me find where it talks about, there we go. Giant squids can grow up to 43 feet long. It's the longest so far they've found. And weigh up to 660 pounds. Talk about sea monsters. That's a sea monster. They have beak-like jaws that can tear into their prey, and then they have that radula as well that aids in eating, that kind of thing. And then you have the octopus on page 432. The Pacific giant octopus might get up to 20 feet long and weigh about 150 pounds. So that's pretty freaky as well. And then you have the nautilus. You can see the nautilus, and we see nautilus shells a lot of times. Usually they're sold at the beach and beach shops and stuff. It's rare that you find one, at least in our ocean. But it is the only cephalopod with an external shell, is the nautilus. And so the other two, they don't have an external shell. They kind of have like an internal shell or, blob there. All right, so that's 21.1. If you have you have your section reviews, so make sure you do section review 21.1. Remember, I'm taking those for grades. I'm going to take them up later on. So make sure that you do them well. Have a good day.